autonomous flight on our remote venue, she will get your code and launch on real drone. Also, Vova Voronin will help her to save your drones. And Victoria Trubitsina, she is responsible for team coordinators. If you have any questions or some discommunication with your team coordinator, please notify Victoria Trubitsina or me, of course. And team coordinators. Team coordinators is very important people on our workshop. Feel free to ask them about anything. And one important thing, tomorrow and after tomorrow, we will provide the competition days. So before our competition days start, you need to choose your role. Who you will be, competitor or expert. You need to choose at least one competitor and at least one expert for next 2 days. Don't forget about it. And our team coordinators ask you about your role in your private Telegram group. So let's brief. From my side, it's over. And let's fly and let's welcome our teachers, Yulia, Timofey.
Hello, everyone.
Hey, hi, guys.
It's great to see you again in the next day. I need to share my screen, so can you turn off your screen?
Окей, Света, перестань шарить экран.
Это чей экран?
Я не знаю, чей это экран. Нет.
Someone is sharing their screen. Антон администратор. Please, who's sharing this screen?
Yes, wait a minute. Anton, finish it. Wait a minute. So now I can tell you about our plan for today, maybe. We have some team today. It will be about sensors and about additional equipment for the drone. For example, LED strip and, for example, our rangefinder. And we tell you a little bit about special features in code. So, okay, very good. Timofey can open our presentation.
Okay. So, Julia, can you see my presentation?
Yes, it's okay. Can you? I think we can start.
Yes, let's start.
So, let's start. So, yesterday, Timofey told you about services and topics in ROS system, in our Clover system. And I tell about one of them. It is get telemetry service. What's mean get telemetry? Telemetry is some data from flight controller, for example, speed or maybe X, Y, Z coordinates, or maybe angles of your drone and something like that. And you can get it in any time when your drone above the Ruka map. If you need to get drone position in current moment, you can use this service. It returns full telemetry from your VCU to the command line. You can see example on the picture. can you show command line? Yes. At the first, I write command service call getTelemetry Aruka map, and I can see these data on the screen. The first one, it is frame ID Aruka map, and the second one, it is connection. When we install Raspberry to the drone, we connect it with VCU through the USB cable. After it, we can see armed or not. And after it, we can see some important information for us. It is X, Y, and Z coordinates. It is in meters. So you can just take 2 or 3 numbers at point and use it in your code in Navigate. But accurately, and don't forget write in this command frame, and you should always write Aruka map frame when you call this service. And don't forget keep drone above the Aruka map, because you can get telemetry, accurately telemetry only above Aruka map. I can Timofey can open. I think Timofey can open simulator, gazebo simulator, and we show you example. The first one, we should put drone above the Aruka map. Okay. Because if you put drone to the floor, or maybe in place where it can't see Aruka map, it don't get his position, his correctly position.
So my simulator is about to start, and what we can do is we can run some program for taking off, or we can even call a special service right from the command line. How to do this? Pretty easy. It's our service call / navigate, for example, and after that I will paste some parameters for navigation, and the drone will take off. So here I pressed tab and it showed me all the default parameters. I need to modify them a little bit. For example, auto arm, I need to set it to true. Frame ID to body, because I want to take off from the ground. And speed, I'll set it to 1.5. And the coordinates, the Z coordinate will be 1.5 meters. So once I hit enter, the drone will take off.
Yes. And it is the same service what you call from your code in Python. Only in Python you call proxy to these services, and you use it in command line and in Python code too. So when we take off, we can call new service. It is getTelemetry service. So now drone can see our Aruka map, and so he can get his telemetry in this time. Don't forget, write frame ID. It is Aruka map now.
Okay, I hit enter, and it will return information about the flight.
Yes, and it is all information what we need to coding. And the most important of it is X, Y, Z coordinates. But you can use another information too for fix some problem, for example. So I think it's
yeah, I can show one more thing here. For example,
yes.
if I want to navigate the drone far away from where it is now, I can set the coordinates of the flight in body frame ID, as you can see. So relative to the drone itself, I will set flight to x 100 meters. So it will fly 100 meters away from where it's now. At certain speed, the speed will be 1.5 meters per second. And the drone will start flying once I hit enter. And when it's flying, I can call a get telemetry service again, and you will see that there is a speed parameters, which is Vx, Vy, Vz. V stands for velocity, and it will be non-zero in x direction. So as you can see, the Vx is 1.46. It means that the drone is moving along the x-axis with a speed of 1.46 meters per second. And it really does. The other axes are around zero, but you can also see that pitch, yaw, and roll are a little bit non-zero. So pitch is like 0.7. The other axes are they are closer to zero. It means that the drone is a little bit tilted on the pitch axis. As well, you can see the voltages, but they're all, it doesn't really matter if we fly in simulator, but in real life, it does matter sometimes. So the mode for now is off-board. It means that the drone is controlling itself off the board. So it's a kind of remote control, but in our case, it is controlled by a onboard computer. But the mode still is called off-board. So let's see our drone in action, where it is now. Yeah, it keeps flying. And I can stop the flight immediately if I call another navigate, and the coordinates will be 0, 0, 0 on all axes, and the drone will just stop where it is now. It will take some time to process, and then it will start to slow down. Okay. So the drone is correcting its position, and now it will slow down and stay. Okay, here you can see the drone is standing still, and we can also call for land. The land service will land the drone. So you can control the drone right from your console, but it's not very convenient because you have to type a lot of text here, and it's not that fast. It's better to use a program for that. So the drone is landing.
So you can use this service to get current position, and you will use it in your final task to get height where you drone now, and maybe to get a position where the drone take off. And for some another thing. So it is a very useful service in for your final task, because you can get coordinate in any time. So if you have any question, you can ask it now. If not, let's go
Okay.
to the next slide.
The next slide will be, wait a second, I'll stop my simulation.
So it is Rangefinder. Timofey, maybe you tell about it.
Yes. So the Rangefinder is a small device that is connected to Raspberry Pi with these wires, and it measures the distance between itself and the nearest obstacle that it faces. There are some limitations on how distant can objects be. For example, it doesn't work quite well after a few meters. So like 3 meters is still all right, but sometimes it doesn't recognize the distance. But if your object is even further away, then it will not see any object in front of the rangefinder. So it is a short distance measurement tool, but when it's in short distance, it's quite accurate, and it can be very accurate, like in 1 meter or 2 meters. You can also call for a rangefinder from your code, and there is also a service that you can call, just like we did with Navigate and Get Telemetry. There is also a service for rangefinder. But how do we access to the rangefinder from our code? Let me demonstrate you how to do this. So first, let's go to the Clover documentation. So there is an article for that, for Lazy Rangefinder, and there is instructions. There are instructions on how to set it up, from the connecting to the drone up to using it. The rangefinder is already enabled by default, so you don't need to do anything with this. And the PX4 settings are also set to work with rangefinder. The most important part begins here, receiving data in Python. So you need to import another part of a library for working with rows. There is a sensor messages library, and you need to import range from that. So how do we put it in our code? Let's continue from our previously written code here. It did work. You remember it from yesterday. And let me copy this first line here and put it around the top of the program. Then what we need to do is define a function. This is a callback function, which means that you do not call this function by yourself. You will subscribe to a topic of rangefinder, and the topic will call this function for you. You can learn more about that when you read about ROS, or you can ask your tutors, the people who help you on solving the tasks. So what you do next is copy this function, the callback function, and paste it in our code right below the services that you made proxy for. Okay, and the Rangefinder callback. What it does is actually prints rangefinder distance, then the data that is received from the topic. This code is written in Python too, so don't worry because of a lack of parentheses here. You can put them if you want. But in Python too, you can avoid using parentheses in print, which I do not recommend anyway. After that, you need to subscribe to a topic of our rangefinder. So what are topics basically? If you remember, there is in the simulator you saw the image here of the image of the camera. This is also a topic. A topic basically it is a way to accessing data. So some program will put the data in certain topic and any other program in ROS can access this topic. For Rangefinder, there's also a program node that posts data into specific topic for data of Rangefinder. And I will access this topic from my code. I can also access the topic from console. Maybe I will show you it later. But first, let's see how to access it in our code. So copy this line for a spy.subscriber. And here in the quotes, you can see rangefinder/range, which is just the path for our topic. I need to subscribe to this topic before any actions in our program begin. And here you can see that the last argument in this subscriber is the name of the function range callback. So this is what callback does. You can pass it as an argument to another function, and this function will call the function, the callback function, whenever it needs. In our case, whenever there appears in the topic, the function will be called. So the rangefinder works many times per second. And once a new message appears, it will print for us this new distance that it measured. But we do not want just print it. We want to access this data in our program and to use it in our code. Because when the data is still in this function, it is not accessible to the rest of the program because this variable is private to this function, the variable where the rangefinder data is stored. So what we need to do is create a new variable which is equal to 0 in our case, in the first case. And then we will say that this is a global variable, global distance, and distance equals msg.range. Okay. That way, we will both print the distance, and we can access the range anywhere in our program. In order to save this data to a file, for example, or to calculate the difference between rangefinder distance and the get telemetry distance. Okay, so what the code does next? It will navigate to certain height, wait for some time, then flies. It will fly to the point. Let me change this point to some other. Okay, and sleeps. Then land. And for the purposes of just demonstrating you how to work with the data here, I will just print again the distance.
And now distance will print it all time because we don't comment it. Okay.
I have commented this print. So the rangefinder callback will just assign this value to the distance variable, and here I can print it, or I can even multiply it with something, or make a sum, or subtraction, and so on. So I think we can test it. Yes, Julia?
Yes, I think it will be good.
Mm-hmm. Okay, the code here, I will test it in the simulator. So let me make sure there's no any errors. Okay. Hello. The link for this article is here. Let me send it to the chat.
Links you have in your schedule for today, and I hope your team coordinators send it to your chat, and now I remember it about this schedule. You have all links there.
There is some error that I can see in this program. Yes, the error appeared after pasting this program. So here tab is one long tab, and here is 4 space bars, which says for the Python this is not aligned. So I need to correct this error real quick. Sometimes it appears, so make sure you always use either only tabs or only 4 space bars instead. Okay, the drone takes off. It's flying to the point. And it needs to output the rangefinder distance here. So yeah, the distance is 1.39 and the drone lands. So for demonstration, just for demonstrating the more usefulness of this, I will put a box in the coordinates 2 and 1, 2x, 1y, and I will modify the program to fly to this point. It takes off and then it flies to 2x, 1y, and it will take him 4 seconds, and then it will print the distance, and then it lands.
And after it, I think we can show how to get height from telemetry and height from rangefinder, and it will be different in this point.
Yes. So as you can see, the height is 1.18, which is less than it was here.
Let's try to get his height from get telemetry in this point.
I hope drone doesn't fall from here. Okay, let's now add the get telemetry to our program. I think it's easier to do here.
Don't forget about Aruka map.
Yeah, as you can see, what I just did is I print get telemetry, and the argument is frame ID equals Aruka map. But this way, it will print the entire telemetry containing all the data that we don't even need. We want to only access the piece of data. That's why I just press point Z in the end of get telemetry after the parentheses, and it will only print one value of Z.
And we have another way to get the parameters. It is create variable, maybe telemetry equals this service, and then you can get any parameters by its name. For example, telemetry.z or telemetry.z.
It will be more convenient for you to understand. So this is one way, remember it. But the way that Julia is telling you about is here. Telem equals. And then we can print telem.z. But there's a major difference between these methods, because once you assign the value to TLM, it will never change again unless you update it manually. So if you want to store some old telemetry in, for example, if you put this variable up to the top of your program, for example, here, then it will not work because it will take the telemetry before the drone even takes off, which is not what you want. That's why you need to do it right before you use this telemetry. So these are two ways of getting telemetry. Let me stick with this one for now and put it in my code. I forgot to change the coordinates. Tele.z, which is not correct, of course.
So it is very useful because Python show line where you have a mistake and this mistake description, and you can just read this log and make your code more correctly.
I think I've messed up with the coordinates again because it doesn't work. It doesn't fly to the point where I need to. But anyway, you can see this. There's a little difference. It didn't see the object exactly before under the drone, but it outputs two values. First value is I think it's a rangefinder value, and the second is telemetry. And the rangefinder value is a little bit less, maybe because the rangefinder is located below, like underneath of the drone. And the telemetry is pointing from the center of the drone. Okay, let's fix this problem. Okay, that's tlm.z. And yes, this is how you access these parameters. You can then modify them the way you want. You can make arithmetical operations on them and so on. All what you need for your program. All right, the next part will be more tricky for some of you who don't really program with Python or with some other language. But I will show you how to use that. So navigate weight, what it actually does. As you could see, I always set some time for the drone to fly to a certain point. For example, here I assume that it will take 7 seconds, at least 7 seconds, or maybe a little bit less, to follow to this point. But I always have to do it manually, which is not very convenient, and it is annoying. But there is a way to avoid this, and it's called navigate wait function. It is described in the code snippets. Let me show you just that. Code snippets. Okay. Here you can find fly towards a point and wait, flying towards a point and waiting for copter's arrival. There are actually 3 pieces of code. I recommend you using the last one because this is one of the most advanced one and yet easy to use and compact. So here you can see a function, def navigate wait, that takes in some arguments. Then these arguments will be passed to the navigate, and also the last argument will be passed to this if statement. How to use this function? Okay, let me just copy it for now and put it in my code. All right, either above or other functions or below other functions, doesn't matter, but do it before you use it. Okay, navigate wait. What this function is actually doing? So when you call it, when it's sitting here, it doesn't do anything before you, unless you call it from your code. So I will call it maybe here after the first navigate for takeoff. I can use navigate wait and put some argument here, but I will do it later. Before I do this, I want to explain you a little bit how it works and hope you understand it. So what it does? First, the navigate function calls just a normal navigate, and the parameters that it is passing to the navigate are the parameters that I will enter later. So as you can see, x equals x means that the x of navigate will be the value that you put here later. And this value will be also not 0x, it will be some number. The y equals y, z equals z, speed equals speed, and so on. Frame ID equals frame ID. And then there is a while loop, and it says while not ROSPy is shut down. So some of the teams already know what ROSPy that is shut down is. I will try to explain it for you. So ROSPy is shut down means that the value of this function will be true when you stop the program. And it is false when the program is working. So why do you do it? Because it is a ROS thing. For ROS, you always need to make while loops that are expected to work infinitely or unless they break. You need to provide them the not ROSPy is shut down, because otherwise the program might just stick and never end, which is not good. So just remember this. This is in code example, and it's very useful thing. So when a program is working, the ROSPy that is shut down is false, but we need to make it true. So we say not. Not will make negative value a positive value. So false will become true. So the while loop will keep working. The next thing we already did, telem equals get telemetry, and frame ID equals navigate target. This is another very useful frame ID. I will show you here. Oh no, I will already close this. I need to show it somewhere in here. Okay, so imagine that you have made a navigate to the point here on the up above the marker 100. And this point in space has its own coordinates. And when I get telemetry from that point, it will return me the x, y, and z from that point as if this coordinate system was was originated in the point where I was going to fly to. And it just tells me how far away I am from the point where I want to be in. So navigate target will tell me how many meters in X, Y, and Z I need to travel to get to the target. And it updates whenever I call another navigate. And then you call a math.squared root function, which is a part of math module. We need to import math here. Yes. And this is actually a Pythagorean theorem for 3 dimensions, which is the, how to formulate it better for you. So yeah, this is the Pythagorean theorem. You need to calculate the distance between 2 points in 3D space, and this is done by the Pythagorean theorem. I hope you are familiar with math. So what it does is tells me if I'm close enough to the point where I want to go, and if I'm close enough means the distance is less than tolerance. Tolerance is 0.2, which is 20 centimeters. And when I am close enough, it will break. So the function will over, and the while loop also is over, of course. But if it's not close enough, then it will just wait for 0.2 of seconds, like 0.10 seconds, 0.2 seconds. For convenience, we need to provide some default parameters to the navigate wait function. Here is already one default parameter, 0.2, but frame ID can also be predefined here. Speed also predefined, and all the XYZ could be 0, 0, and 1.5 because I want to maintain the height of 1.5. And now I will always use navigate wait function instead of normal navigate, except for takeoff. In takeoff, you don't really need this function. You can just say navigate and then sleep for some seconds. Okay, and how do I use it in my code? So navigate wait and the coordinates where I want to go. For example, 3, 2. Once I've reached this point, I want to print the distance then I want to go to the point 1, 4 and also print the distance. I don't need to use rowspy sleep anymore. And let me print some telemetry here. And I will do it the way that I showed you previously. Get telemetry from ID equals argument v. Okay, and land. Or it's better to land in the original point, so navigate wait and blank nothing in the parentheses because the default values are 0, 0, 1.5, which is just the original point where I start the drone, and land. Okay, this type of program is more easy to modify, to change the points to the points I need to fly to. And let me put it in my simulator and test. I'm creating a new file, pasting this code. Let me check for errors. Okay. And run Gazebo. All right, I'm ready to start a program. Python nav w.py, and let's go. Yes, the drone is taking off. Then it will go to the points that I have provided. Yeah, and it is immediately going to the point. Once it reaches this point, it will go to the next one. And there's also some output. Yes, the output is here, and it will go to the next map. Yeah, now it outputted two values, one from Rangefinder and another from telemetry, and now it's going back to the original start.
So we recommend you to use this function navigate weight because sometimes you can calculate RSPI sleep time incorrectly, and then your drone can't fly to the point and start the next command. So it's fly to the point number one, and he don't
Reach.
and it don't reach first point, and it will fly to the second point. So or you should calculate time very accurately, or you should use a navigate weight function.
Okay, so this is what navigate weight is, and working with rangefinder and telemetry as well. We can move to the next topic. Our next topic is LED strip indication. So Julia, can you tell us about this?
Yes, of course. So in our drone, we have LED strip, and you can indicate with it different actions. For example, if you take off, you can make LED strip green, or if you reach first point, you can make LED indication red color, for example, and you can control LED strip from your code. I think Timofey can show next slide, and there we have a link to the Gitbook. Can you press to the link? Timofey, press the link, please. Okay, there we have article about LED strip, about indication, and how to use it from Python code. The first one, we can see some parameters. I think what we have in basic code, in basic function, but you can define new functions. The first one, it is fill. This yes, fill. It's fills the full strip with the requested color, for example, green or red or blue. So all LED strip will in this color. The second, it is blink. Blink, it's parameters allow you turn on your LED, and after it turn off it. It will be like blink. And you have fast blink too, and some another parameters. So what will you use in your function to make effects to your LED strip? So let's go to the code. The first one, you should import library, and it is yes, set LED effect. And after it, don't forget about proxy to this to the service set LED effect in your code. You can just copy it and paste in your code where your drone navigate.
Here you can.
The first one, yes, in this code. The first one, this copy.
And also we'll need to copy this from here.
Yes. So now we can use all these functions in our code.
We can hear someone.
Yes. Okay. Mute your microphone, please. We hear somebody. So the next one, we can just write command set effect, and Rgb variables. It's mean how what color you will have. For example, the first one R, it is red color. The second one, it is G, it is green color, and B, it is blue color. So if you write max value to R variable, it will be red green. Your variable in can be changed from 0 to 255. And if you want to get green color, you just write 0 for the red color, and you write 0 to the blue color, and you write max value to G parameter, to G variable, and it will be 255. So it will be green color. And if you need to get color maybe like white, you can set all these values to maximum. And if you need color like pink, you can write a little bit blue color. For example, B will be 100 and R will be 200, for example. So in this way, you get another color. So you can use some effects in this function. For example, if you want to your LED strip blinked, you should only add effect blink before you declare colors. So I think we can add this one effect to our code and look what will.
Okay, I will choose the blink effect, and I'll put it in the code after the takeoff. After the takeoff, it will start blinking with a white color, and it will be blinking
All time.
all the time.
But if you want to stop blink and turn off your LED strip, you should write set effect with Rgb variables equals 0. All variables should be 0.
Or you can just write set effect with empty parentheses.
Yes, maybe. We have LED strip in our gazebo simulator too, so you can check it there. And when you will make your task today, you can Rangefinder and LED strip in the simulator. Oh,
so as you can see, it's already it already has some effect. It is a rainbow effect, and after I start, it will change. I will zoom into the drone so you can see. First of all, it will turn purple because this indicates the off-board mode. The off-board mode means that the drone is controlled by a computer. After it takes off, it will change the effect to the blink.
And it has red blink effect if your battery is empty.
So yeah, it is already blinking, as you can see, white and then black. Okay, let me just stop the program. The drone will stop soon. And I want to show you how to access this LED effect from your console.
We have example in Gitbook
Yes,
too.
there is a
So, yes. So you can call this service from your command line with the same effects. If you don't want to write a lot of words, you can use tab there. Just write part of word and after it press tab.
So one of the effects is fade, and it turns certain color, then slowly change it. So it did change the color slowly. I hope you have noticed. I can call it another time with a different color. It will turn red now. Yes, but this color is too similar to the previous one, so you didn't even notice what it did. Yeah, it starts to change to green. There is also rainbow the easiest effect. You don't need to provide any colors for that.
You can try it in your practice today, all these effects with your team coordinators.
Okay, yeah, and now it's rainbow. In a real drone, it will be much brighter.
And more beautiful.
Yeah, it's very beautiful, and you will, I think if you use that effect, you will notice that pretty much. All right. So the next topic is creating a file.
It isn't it is a topic not from our system, not from Clover, but it is typical thing for Python language. How we can save any information to file. In easy code how to make it. The first one, you create a variable, you declare it, for example, f, and you can write command open to create or open file, for example, test.txt. After it, we can write information in this file. If you write f.write, and after it, your information. You can add there any text or any numbers or maybe any information what you get before. For example, you can write the measurement from Rangefinder. And after it, you should close this file to save it, and it will be saved in folder where you start your code. And after it, if you want to read it, you can open it in Nana, or you can print it to the screen in command line. So let's start it. Let's try it in simulator, I think, too.
Okay, I will
we can.
create a new folder.
Okay, yes. Now, let's create file and.
You want to create it before we
open it. It doesn't matter.
Just if I open it.
Mm. After it, you can write any information there. If you write some text, you should use double quote. Don't forget about it. And /n, it is the next line. It means a new text will be on the next line. And after it, don't forget, close it, because if you don't close it, it will not save. And you forgot about скобки.
Yes.
Yes.
Скобочки close не закрыла.
As you can see, I just ran the code and it created a file.
And now in this file will be 1000, if I remember.
Yes.
Yes.
And the next line, as you can see. So
10,000.
if I run this program again, it will just add another line of 1000 to the code, as you can see. Yes, it just adds a line.
To end this file.
Because we use a argument. Let me show you. So there is the second argument when you open the file, and for now it is a. If you wanted to rewrite the file every time to make it new file, you need to set it to w, which is right, and it will delete all.
So delete your old file and create new file with new information. So be careful with it.
Here you can see there is only one line of 1000, and I run it again, and it's just 10,000 line.
Value. Yes. And if you open it with R argument, it will be open only for reading.
So you will not be able to save anything. You cannot save anything now.
And you.
Yes, there is in there the exception.
You can't write something in this file because it's opened only for reading. So
as you could see, there is no dedicated function to creating a file, but it will create the file if it is not, it doesn't exist.
So I think that's all for today from our lections. And now you have 10 minutes for relax. And after it, you will connect to your team coordinators and start make your tasks for today. I tell a little bit about it. Task number 1. You should write a program where drone take off maybe for 1 meter or maybe 1.5 meters. And after it, you should turn on your LED strip in green indication. And after it, just lands your drone. The task number 2, it is write a program where drone takes off and fly to point. We get you your UTM coordinators, get you coordinate of this point in your Telegram chats. And after it, get distance to the object under the drone. It will be placed on the floor, little box. And after it, you should save it to file, save this distance to file. And after it, come back to the start point and land there. If you want to come back to start point, you should save this point when you take off with get telemetry service. So you should take off, get telemetry, save X, Y, Z coordinates to X, Y, Z variables, for example. And after it, when you will finish your flight, you should fly to this X, Y, Z points, XYZ coordinates. Do you have any question? No? Nobody have questions?
They have questions, but they ask them in their chat.
Okay, very well. So then thank you for, okay, how to save measurement to a file. Come back, please, Timothy, to previous slide. If you want to save measurement to the file, you should create or open a file, and after it, write the not new coordinates. You should write there your variable distance from the code. Can you open your code, please, where we get distance, please? So we have the variable distance, and you should save it to file f.write, and there you can you should write distance, double quote, okay, and a. And in file, you should write distance. And after it, before stop program, you should write close. It will save your program, your file. Okay, that's very easy.
Okay.
Okay.
I think that's it for now, and we can proceed to our break. And see you later.
Yes. See you after 10 minutes, in 10 minutes. Bye. You get new links to the Zoom with your team coordinators in your Telegram chats. Bye.
But I have, if he talk, I have to type. If I want to talk to him. This one. Let me mute. Let me mute it. Let me mute it.
喂，大家中国的团队，你们在不？就是我们现在呢，每个团队需要进去另外的一个 Zoom 房间，所以呢，请你们开个我们 Telegram，然后看一下最新的链接，然后进去耐心的 Zoom 会议，听到请回复。喂。
Guys, We will start our brief in 2 minutes. Ты мне включи.
Попросил сейчас.
Да, я включила.
Включила. Все, сейчас. И потом скажи, что любой просто тест, там слово любое.
Okay. Guys, where are you? How are you? You can, while we await another participants, you can share with your impression of this day with microphone and camera. It's up to you if you want. So Singapore is here, Emirates is here, China is here, India is here, Ghana is here, China, Singapore. Great, great. Okay. Do you hear me? Is okay? We have some troubles with platform. Okay. Oh. Okay, guys. So let's start our brief. Our brief will shortly. First of all, I think with their impressions of this day, our teachers will share it with you. And after that, I will tell you about some important things for our next days. Okay, Yulia, Timofey, welcome. Some words about this day and finalists.
So, hi guys. I saw your today's results, and it was very good, but not all teams finished all tasks for today. I think you have communicate with your team coordinator, and they can help you to make try attempt. And I hope it was clear for you our lesson today. And if not, you can ask in general chat or in your chats, in your groups, in Telegram, all questions, and we answer for it. But I congratulate you with finishing this day, and thank you for hard working. Timofey?
Yes, I'm also impressed how you solved this problem, because yesterday it was we did very basic programming, and today's programs look much more sophisticated than yesterday's, and I'm glad that you all now understand much more about aerial robotics and the Clover platform, and I hope if you will continue to learning these new skills, you will be able to create very great projects, and you can make the applications in real world tasks.
Okay, thanks, Timofey. So let's continue our brief. Now I will tell you about our plans for next days. So as you know, tomorrow and after tomorrow, this day will with our performing with competition task, and you need to understand your competition task. Please make a screen of this slide, and tomorrow at the brief you can answer all your questions, and we will answer it for it. And tomorrow at the briefing, we will share with you schedule of your day. And next, don't forget about reflection on the day. Fill the form. Our team coordinator will share with you this link. Your report, it is very helpful for us, and we make each day is better. And the last one. So during our camp, you get new knowledge, new experience. Your expand your networking community. You involve in our network community, and it's very good opportunity to share your opinion with us and with all participants from this camp. And we would like to get from you some ideas about how do you think to share this experience in your country, in your educational institution, maybe etc., maybe another ideas. But this slide, it's such as example, such as a template. Oh yeah, I see some errors in this because it was a draft. So you can share with us your ideas and experience at the last day of our camp. It will happen in 26 July. You will have 3 minutes. 3 minutes. It's the last day of camp. Yeah. Okay, and I think it will be a great opportunity to continue our partnerships and our cooperation for next developing our skill in your country and another educational institution. And thanks all for your hard work for today. It was incredible. It was interesting. I have connected to per each team, and I follow for your process. It was interesting. Thanks for our teachers. Thanks for our team coordinators. And see you tomorrow at our competition days. Be prepared to get it and to perform the final task. Bye-bye. See you.